Deductive reasoning is just logical thought. If you can order something logically, you can do deductive reasoning. Okay. What I have up there is just what the deductive reasoning word is kind of broken down into. So basically, you give yourself a set of circumstances that are happening. Some part A happens, part B happens. You make a conclusion based on what's going on. That's considered deductive reasoning. The way you guys are going to do it is I'll give you like a statement and say this statement definitely happened. And I'll give you another statement and say this statement definitely happens. Based on what those two things are, I would ask you to make maybe a conclusion based on that. There's going to be two laws that we go into that are going to be applied in terms of what you guys will do conclusion-wise. Okay? They're going to be called, which ones we have? You guys do law of detachment and I think law of syllogism. So it's those two laws that you're going to use to get your conclusions out of. They're going to be written out kind of formally, like they'll tell you what they are, but the way they're applied, you probably already do. Like if I just gave you the statements and said make a conclusion, you probably could do it without knowing what the laws are called. Okay? All right, so forget that. All right, so first one would be law of detachment. Okay, the big difference between them is law of detachment is kind of linking together two statements, where a law of syllogism is going to link together like three things. It's actually going to look kind of like transitive property. So what this is saying is, the way it's listed up there is saying, look, I've got a conditional statement given to you. So the P implies Q. Remember, this thing is related to a conditional statement. So it'd be like, if P happens, then Q is going to happen. So the law of detachment says, you have a conditional, someone comes along and tells you that hypothesis definitely happened. And they say, based on that, make a conclusion. The obvious conclusion is for you to say, the part that comes after my original conditional, it happened, like the conclusion is. So that means that if you had a problem like this would be an example that would say use law of detachment. And again, even if I did not have law of detachment up there, if I gave you this situation, you could probably come to some kind of conclusion. I would assume most of you guys have some form of deductive reasoning, whether you know it was called that or not. Okay. So the way this is set up, and the reason it'll tie into what's up there is, if there's lightning, then it's not safe to be in the open. That would be your original conditional. So this is like a given statement. All right, and then it turns around and says, all right, this person sees lightning. This is basically saying, look, I know that hypothesis happened. All right, and it's saying, look, since I know this is a true statement and I know this happened, what is the only possible conclusion that's going to come out from those two things? If you see, like guys, if you see something like this, like literally all this is asking is, when it says what's the conclusion and they only give you one conditional, you just kind of restate what the conclusion is up there. That's all that's going on. All right, remember this portion was the hypothesis, that's the conclusion, so they kind of hint at it in the directions where it says what can you conclude. If you go beyond that, you're overthinking this stuff big time. Okay? All right. The other law is, this is something where you have to have two kind of conditional statements given to you. So what's going to happen with this one, where this is going to be applied, is they're going to give you a conditional here, and they're going to give you another one here. But the way these things are going to be formed is that these two statements are going to have to overlap each other. And it's saying, look, based if all that happens, then you can form a new one that is a definitely true conditional statement based on the statements that are up there. So again, you're not adding to this. You're taking things that are already there, you're kind of repositioning them so that they create a new kind of conditional statement. So this works more like the transitive property kind of thing works. Okay? So if I had that kind of situation going on, where it's saying, here's one conditional statement, there's one if then, here's another one. All right, and if I look at these two conditionals, you'll have the conclusion of the first one becoming the hypothesis of the second one. So what you're creating there is a distinct overlap. So it's saying what this law kind of does is it says if you've got this conditional and this one, and you have an overlap there, if you kind of eliminate the overlap part, you can take this hypothesis and this conclusion and create a new conditional statement. All right? And technically the way you're working with this is you're saying this has to be true and so does that. Okay, so what would go in the blank there would be this portion. All right, because what you're doing again is you're just kind of taking out that overlap portion. So here's my new hypothesis, there's my new conclusion. These two will come together to create one new conditional statement. So this would be like, if it's July, then you work in a smoothie shop. Okay? The last bit, okay, so before I do the truth table stuff, all right, I'm going to make sure you kind of remember what these all stand for. Okay? Guys, you should have had there, okay? Making sure on the second one, if you're writing these out, to remember that all of this stuff is on the left-hand side of the arrow, so this entire thing is the hypothesis. So this entire portion right here would come before the word then. All right, and that's the only thing that's after then, so that's the only thing that's the conclusion. All right. So now, where these symbols are going to come back up. All right, you guys are going to be making these things called truth tables. Again, you see this for like a day, so don't freak out too much. Okay? You need to be able to do the basic ones, and like I'll give you ones that are a little bit more complex than that to attempt. If you get them, great. If not, it's not that big a deal. Okay? All right, what these things get used for, in terms of a logic course, these things are used to tell whether or not you have a good argument or not. They're called valid statements, or to prove something is completely invalid. They're very odd looking if you're not used to seeing something like this. And the basic, for you guys, it's probably going to be coming down to you just got to memorize this stuff. To be able to get the process down, it would take probably a week or so of actually doing just truth tables, and then you would actually get the process, but we just don't have time for that in here. That's why it's just kind of an add-on section for, I think it's just for the, I don't remember if it's just for the honors portion or not. All right, so the way these things are set up is you guys are doing arguments with two things in them, meaning like the P and the Q that was up there, that's what I mean by two arguments. There's various ways to link them. We've got conditionals, you got biconditionals, you got the conjunction or disjunction, which would be the V and the upside down V's. What I'm going to do is I'll give you like a table that's got the rules on them. And it's basically going to come down to you guys have to just kind of memorize the rules right now. I'll try and tell you how they're formed, but there isn't much else to them for, like I said, you guys. All right, so the way these things are set up, the truth tables are going to be set up such as you'll have all the stuff that's involved set up in a separate column. Every time you create a truth table, these first two columns will always be the same. So you'll have two things, two arguments, P and Q, and they'll be linked together somehow. This column for P is always set up this way. Q will always be set up this way. All right. The T's just stand for like a theoretical, like true, and the F stand for a false. What these two columns do is they give you like every combination of what could possibly happen between these two statements. Like I could form a statement where this is true and that's true. Like I could create a P and a Q where they're both true. I could create a statement that's P, that's a true thing, and Q is a false thing. I could create this false and true and both false. Now, the columns that come after these two, like these two are set, this is how you start every truth table. The ones that come after that are going to be formed by whatever the heck is in the actual statement. Like if I just had this in there, if this was the entire statement I just created, I would literally just copy this column down. Okay? That symbol, remember, is for and. Okay? The way this works is if you ever run into this in some kind of argument, the letters that are up there, these are basically going to be the things that you reference back to. All right? And again, this is going to seem really odd with what's going on. Okay? All right, so the way you fill these out is you go to the columns that are on either side of that symbol, and you just go down the columns and compare the values that are next to each other. So the values here are either T or F. The way this symbol works is for you to get a result value of T over here, these have to be T. Anything else, if you see an F, will result in a false outcome. Okay? Meaning that if meaning like if this was a true thing and that was a false, if I were to put these together and create a statement with an and in it, it would create a statement that basically doesn't make sense in terms of trues or falses. Okay? So essentially what you guys are looking at and the way you're probably going to have to use it now is this whole thing needs to be kind of built up as a rule or something that you can look back to use to form your truth tables. So if you ever see this symbol, you'll come back to this and use what's up here to try and figure out what should go in the column. Okay? So what I would say right now is just kind of write them down and then we'll kind of piece them together as we go. Okay? All right. The next one, again, the first two columns are identical. All right? What's up there now is simply going to give you the rule for what would be a disjunction. Like this would be your or. Okay, so again, the way these are formed, and when I actually do a problem, these two columns are going to be the ones I look at. Right here is the rule for what happens when you put that little symbol in there, meaning you're not going to copy straight down what it is. You're going to go to how these two things compare to each other and trace them. Now, the difference between an or thing means that if you only have one bit of it true, that makes a statement. Or just means one or the other thing could happen. So if you have something that's a true statement in there, you link it together with an or, that means it makes the whole thing true. Okay? And means you need both things to happen, or means you only need one of them to happen. All right? The other two you guys will use is that one. All right? Essentially what happens with this one is wherever the arrow is pointing, is like the result. Okay, so if the arrow kind of points to a T, meaning that you've again gone back, you've looked at a column that's on each side. So if the arrow is pointing at a T, like if I drew an arrow between them, like this T points to that T, so the result is T. Like this points to an F, so it goes there, that points to a T there. The bottom one's the only one that doesn't fit that kind of rule, but you treat that one kind of like it's a double negative. And then the last actual rule that you guys need to write down is the back and forth arrow. And back and forth just means it has to look identical on each side to give you like a positive result or a true outcome. Okay. If you don't have them, if you lose this or whatever, if you look in the book there's I think one chart that has all of them listed together that you can kind of reference back to. And I'll do like one or two from scratch just so you can see kind of what's going on. Okay. So not that much long. What was that? The statement I had you guys write out that just had the symbols in it, not the words. What was that? Like before the slides. What was the top one that just had the P and Q?
The squiggly line with P. And then,
arrow?
Yeah.
Like that?
Yep.
Okay. All right. So this, it would be considered a pretty easy truth table if I said, here's a statement, create a truth table on it. Okay? Because there's only 2 symbols up there, there's only 2 statements, it's a really small truth table. I could tell you from the start of this, since there are 2 letters and there are like 2 symbols here, that means I'm going to create a total of 4 columns because there's 4 things there. So me starting this, again, like for you guys, this is kind of a matter of just seeing if you can do these. We don't really have time to go into how they get used. Okay, but this would be something like someone goes, okay, I'm going to create, this is my logical argument. And what this table would do, it would either prove or disprove that this argument is a valid argument. All right, but because I don't know what P and Q stand for, I'm just creating something where I could plug anything I want into P and Q and it would always be true or always be false, that kind of thing. The way you start it is these first 2 columns, like I said, are always the same. True, false. Okay, so that's like, if I give you a truth table to do, that's like 1 point. You can start that off good. You got 1 point out of 3 or whatever I give you, 3, 4, depending on how big it is. Okay, the next 2 columns are going to encompass the symbols that you have there. And what you want to try and do is you want to try and, if you've got like an arrow, you want to try and do the work on one side of it, then on the other, then link them together. So like that's on the left-hand side, that's on the right-hand side. I've already got that as a column right there. That means I need this to become a column now. Okay? So that means I'm going to add that symbol to it. Now I didn't have that rule up there, but remember negation just means flip it from like a positive to negative. So if I've got this as, this is the column I'm referencing. Okay, so the letter tells me where to look back to. If I'm negating this column, meaning I'm just going down the column and I'm flipping the signs from a positive to a negative, in terms of true falses, that just means changing it from a true to a false. So if I go column by column, so the first one I run into here is a T. If I negate that, it becomes false. The second one is a T. If I negate that, that's F, T, T. Okay? The last column, now that I have both sides of the arrow, I've got this side and I got that side. Okay? When I'm doing this, now what's going to happen is, I kind of mentioned it, but the rule is wherever that arrow is pointing is going to give me the result I want. So now what you're doing here is I'm taking this column, so I'm going to look back at this column here and this one here. And I'm going to either like physically draw an arrow between them or just kind of do it in your mind. So I go to this column, which is right here, and I draw an arrow to where the Q is. And I do it row by row. Like again, usually you do this mentally, but for you guys, this is fine. So if I go row by row, I look in this first row, it starts with an F, but it points to a T. The way the rule goes with the conditionals is if it's pointing to a T, the result is a T. This is the column you write the kind of the result in. If I go down to this one, it's pointing to an F, but since it starts with an F, it's a T. Okay? This one here, it's pointing to a T, so I can put that there. That's pointing to an F. It does not start with an F, so that means that I can take that actual result. That would be a complete truth table for that one statement. Okay? All right? You guys are going to have to be able to do small ones. And you don't have to do like big ones. Okay? Let me do another one that's got like 4 columns because those are pretty small. Should I start with P or Q? It doesn't matter. P. P, and then we'll do that symbol. I'll do another 9. All right, we'll do this because this is still going to be 4 columns, and it's considered a fairly basic truth table because there's only 2 statements there and there's only 2 symbols. Okay, so my base symbols are just the P and the Q, the 2 letters. So again, just like the one over there, I'm going to start it with those. All right, and these are always filled out the same way. So guys, if you can do that, I'm telling you, that's going to get you a point on the test. You need to be able to at least do that one. All right, then like I did on the last one, okay, I'm going to kind of work on both sides. So this is like the big linking symbol. So that means I need to have one column for what's on the left-hand side, which I do already. It's right here. And then I need to have one column for what's on the right-hand side. Well, I don't have that yet. I just have Q, so that means I need to add a column for that. And again, that symbol means negate, so that means I go up here and I just switch the signs of whatever the heck's it. So this will be false. Because I'm taking, again, this is the column I'm looking at, and I'm just switching all of those. So anywhere I say T, it's going to change to that. That's going to change to that. Okay? Now the last thing is going to be, I have to kind of go through, again, I'm doing this row by row, and I'm looking at this column here, which is this one, and the one that's over there, meaning I need to kind of ignore that one for right now. Okay? And I'm just kind of throwing that symbol between each thing. All right, so what I'm doing is I'm going to go row by row. I'm comparing these two. This is the symbol that's between them. I go to what the rule was that was up there, and whatever the rule tells me to do when it looks this way, I put the result there. Now with this symbol, the only way I can get a T over here is if the two on each row are both T's. Like this one up here, there's a T here, there's an F there. Are those both T's? Are they?
No.
No? Well, like two people can read that? That's not a T, guys, it's an F. Put an F there. Are these both T's right here? Right here and here?
Yeah. Yeah.
Yeah, who said that? Come on. So that's a T. So with this symbol, the only way when you go row by row, when you look at each side, the only way I can get a T result here is if they're both T's. All right? This one right here, are those both T's? No. Are those both T's?